Hello all, welcome to the next online meetup of AWS User Group Punjab. Today we are blessed to have Abhishek with us, who's the AWS developer advocate. Um, uh, he has been AWS with AWS for past few months now. Um, Fun fact about him: he is a fitness freak, loves to do um, workouts in CrossFit style, and also don't shy away from watching horror movies, which I don't like to watch at all. He's a particular fan of, particularly he's fan of The Walking Dead,
Yeah,
and of course he, yeah, likes spending time with the
yeah,
family. So today he is going to discuss and share more details on how to deploy AWS Lambdas using the Golang. So
yeah.
over to you, Abhishek.
Thanks, Aman. Yeah. Hey. By the way, Walking Dead is like a episode or rather a series on Netflix. It's not a horror movie per se, and it's not that scary once you get used to the zombies in season one. Then it's like they go in the background and the real thing is happening. The real content is there. But anyway, sorry, I'm not going to talk about that. Thanks so much, Aman. And thanks everyone for folks who have joined, for tuning in on a weekend. I really appreciate that. So I'm Abhishek. I'm based here in New Delhi. The weather here is improved, over the past week or so, like from like 38, 40, 41 to now it's down to the high 29, 30 or something like that. So it's definitely a huge relief from that sense. Like Amandeep mentioned, I've been at AWS for about 4 months now, and this happens to be my first talk at an AWS user group. So thank you again, Amandeep, for having me here. I really appreciate that. And although I work on a lot of things as my role as a developer advocate, I work on a bunch of things, including databases, containers, so on and so forth. But in the context of this session, all you need to know is that I love the Go programming language. I'm super passionate about it, and really my goal today is to sort of help you get started in terms of using Go to build serverless functions on AWS Lambda, right? And don't worry, I'll not have this PowerPoint in front of you for the next 1 hour. I just have very few slides to set the context, right? Just to give you an introduction, and then I'll move on to the main agenda, which is kind of this, not similar, right? So I will be spending most of my time in the IDE. I'll be typing out code and talking to you at the same time as well. Hopefully there won't be any fires or anything. I don't have any servers running here, I promise you, right? So that's what I'll be doing, and mostly it'll be live coding, right? And just discussions. But before I move on, I want to cover two very important points really quickly, right? One is the motivation, and second is the assumptions, right? So really, what my goal is, why am I motivated to do this, right? When you sort of try to learn something, and how to build something by stitching, when I say something, I mean applications, specifically on the cloud, by stitching different components, different services together. The first step is often the hardest, right? And at least that's the case for me personally. I find it hard to get started if there is not enough material and enough resources out there, right? So you need to have something set up locally on your laptop, excuse me, and you need to set up and configure things in the cloud. You need to make sure you have integrated different services properly, right? Just too many things to think about, and that's why my goal here is to make it easy for you to get started with Go and serverless app dev using AWS Lambda. So really, hopefully, you will be able to go back to this video, and this is all going to be recorded and everything, and be readily available to you. So you will be able to hopefully go back and follow along, right? And I think that will make your getting started learning curve a little easier, a little less steeper, right? So that's what my motivation and the goal is. And the second thing which I want to talk about is we have limited time. I have about 1 hour. I have already spent about 5 minutes, right? So 55 minutes to go. I won't be able to teach you like everything from scratch. The Go programming language or AWS in general or Lambda or DynamoDB or API gateway. Honestly, I won't be able to do that. I need a few hours a day daily for the next few weeks to be able to, that will be a big project for me, right? So I have a few assumptions, okay? in terms of what you already know. And these are not mandates. These are just my assumptions, right? So the first one is you have some knowledge of Go, right? So you know things like what a function is. You know how to write a hello world program. That's it. Nothing more than that, right? Some knowledge of Go, and you are at least familiar with AWS. What do I mean by familiar? So you just know, like, you need not be an expert, right? You maybe know, you've heard of Lambda, like, yeah, it's a serverless capability, serverless compute in the cloud. Maybe you know what is DynamoDB, it's a serverless NoSQL database. Maybe you've heard about API gateway and and things of that nature. So if you've heard this terminology, maybe you know one-liners, that's more than enough. If you don't, it's okay. You can always go back and take a look. It's not a big deal, right? So, but that are just a couple of assumptions which I have. And moving on to what I have in store for you today. So it's what I'm going to cover is split into three like large categories or parts, right? So one is I'll start off with a very, very simple sort of a hello world Lambda function using Go, and I'll deploy it. So that's part one, super duper simple. The second part is I'll bring in DynamoDB NoSQL database into the picture, and I'll update the Lambda function to show how to persist data from a Lambda function into a DynamoDB table. And lastly, what I'm going to do is sort of wrap it up, and I'll talk about infrastructure as code as well, and how to use Go. Again, the theme is Go here, right? How to use Go to manage your infrastructure, your code, your Lambda functions, your DynamoDB tables with something called the AWS CDK, which is the Cloud Development Kit, right? And that's it, right? This is a high-level overview, and I'm going to just stop the presentation now. Go over to VS Code. I have like a blank project set up here, nothing else, and I will get started. I'll take a quick sip before I do that. So I'll do that in between. So I hope that's okay. I like doing that. Okay, cool. So like I said, I will start off with a very, very simple hello world Lambda function in Go. So let's dive right in. What I'm going to do is I'll set up my Go project now. So what I've just done is a Go mod init, right? You have a go.mod file, which is created here. That's it. Like, I'm just talking about Go modules here. If you haven't heard about it, it's okay. You can always check, what are Go modules, and it'll give you the information. So basically, the TLDR is that this is all about dependency management, right? So I just set up my Go module, and I'm going to grab a couple of packages or dependencies, right? Which I'm going to use for this Lambda function. So the first one is a package called Lambda Go /events, and the second one is Go Lambda, AWS Lambda Go /Lambda. And I'm going to talk about these packages. Don't worry, right? Let me just go with the flow and show you what I'm going to do with it, right? So that's done. Now we can go to the part where I start writing some code. Okay, so I'm going to create a main.go file and start writing code. Right, so I'm going to create a package, main package. Everything starts there, and I'm going to have a main function, right? Everything in Go starts with the main function. This is the entry point to your application, whatever kind of application this is, CLI, web server, things like that. Everything starts with the main function. So what I'm going to do here is use this Lambda package, which I just said, and call something called lambda.start. Okay. Now I'm just starting backwards, working backwards here. Okay. So don't worry about it. I'll explain everything as I move along. Okay, so what is this start function? It just needs something called, it basically needs a handler. A handler is another function. That's all you need to understand for now. So let's create that handler function now. Okay, function handler, and obviously you need to have some sort of a signature for this, right? So in this case, what I'm going to do is one of the arguments will be a context, a Go context object. Again, you don't have to worry too much in terms of what this is. This one is important. So I'll have a request object, which is going to come from this events package. And this is going to be an HTTP, sort of a object from API gateway. Okay. And I'm going to return something, of course, right? And what is my return type going to be? My return type will be an HTTP response. Just give me a second. I'll grab this. And an error. Okay. So this is like a signature of my Lambda function, and just to make sure this compiles, I'm just going to write some, boilerplate code for now. So we have the rough structure here, right? So just give me a second. I'll do go more tidy to clean things up and pull in the dependencies just in case there was some issue. Oh no, actually we don't need this. right now, so we should be fine. Let me stop this. Okay. So we have a rough function here, and what am I going to do with it? I'm going to keep things very, very simple. Like I said, this is a hello world Lambda function. So the first thing I'm going to do is look at this object, right? So basically, this function tells me, hey, my Lambda is going to receive something from the API gateway, from the Amazon API gateway, and this is the structure, the format, and I'm going to return something to the API gateway or return an error if that's the case. Okay. So what I'm going to do is use this request object to get the body. So the Lambda, ultimately, we are going to, as the users or the clients of this Lambda function are going to send something, some information, right? So that is going to be encapsulated in something called a body, right? This is just a string data type, that's all. And I'm going to store that in something, and I'm going to name that payload, and I'll just print it out just to begin with, right? So I'm going to say, hey, got payload and payload, right? Very simple, just sort of hello world kind of a thing, like I said. I'm going to create a response string as well. What I'm going to do is just say hello plus the payload, and I'll, we all like adding exclamation marks, right? So very simple. I get the payload from the request object. I print it out. I just add on and embellish that payload to add hello and an exclamation mark. And what I'm going to do is ultimately return this response in this object, in the HTTP response object here, right? For API gateway, ultimately to receive it. So there is a body field here in the response as well. So I'm going to set this response code. That's it. Very simple. This is literally it for in terms of the hello world Lambda function which I have for you, right? So what I'm going to do next is sort of build the code and deploy it. That's what I'm going to do right now. Okay. So what we can do is there are multiple ways for you to sort of deploy the code to Lambda, but I'm going to create a zip file here, right? So first, let me build this function. Okay. So what I'm going to do is do a simple go build, and the name of my binary, I'm going to create a binary here, is going to be demo, right? And I'm just notice I'm using this Go OS. It's a Go environment variable, one of the Go environment variables, and I'm sending to Linux because that's what my Lambda is going to run in, right? It's not, I have a Mac here, so I'm not going to like compile it for my native Mac. It's going to run in a Linux environment. So that's why I'm going to make sure that the binary is compatible, right? And Go build, you should be familiar with this if you have, sort of played around with Go, but all it's going to do is create a binary named demo. That's it, simple. If I hit enter, and I'm going to just increase the font here a little bit, just in case you're having issues. So that's it, right? So you see we have a binary called demo, and all I'm going to do is make a zip file out of it. So I'm going to have func.zip, and I'll include this file demo. That's it, simple, right? So now I have a func.zip file as well, and this has a demo binary. Okay. Let me go over to the console. Now this is the AWS console. I'm here. I have an account, of course. I'm logged in. All I'm going to do is hop into the Lambda part of things. And I will go ahead and create a Lambda function manually. So I have a few demo functions here. Don't worry about that. So I'm just going to create a function. I'll start with a simple hello world function from scratch. I'll do it manually just to show you things. Of course, I would have used the CLI or some other process, but I'm going to show you this manually now. So I'll just call this demo func. My runtime. What is my runtime? Of course, I have a bunch of options, but we are building Go. I love Go. So I'll have Go as the runtime. And that's it. We don't have to think about too many things right now. I can just go ahead and click on the create function button, give it like a few seconds. I think mostly it takes a few seconds. Let's see. It's a demo, so you never know. It's live. All right, not too bad. So this is done. So successfully created the function. You can change its code and configuration, blah, blah, blah. Now, let me show you a couple of things, right, in what's there in this function. So there is this code part, and I'm going to come back to this. Let me show you the configuration here. So there are a bunch of things you can configure, including environment variables, and I'm going to show that to you as well. But let's go to this permissions part. So every Lambda function is associated with an IAM role, which is sort of automatically created for us right now, as a part of the creation process. So let me open this role. So basically what this role is about is every role is going to have a bunch of permissions, and it tells you like what this Lambda function can do in terms of, say, if it has to integrate or invoke other services, right? And I'll show you this in action as well. So this function, or rather this role, which was automatically created, it just has a simple set of permissions or policies for now. All it can do is interact with CloudWatch and push the log streams there for the function logs. Very simple. I just want to show you this because we'll come back and sort of modify this function later on. Right, so that's that. And in terms of the code part, let me upload the code right now. Remember that zip file I created, so I'm going to upload it locally from my local machine here. I have the function here, so you see I'm in this demo folder, and I recently created this func.zip file, right? So just a few minutes back. So I'm going to click save here, and just going to upload it right now. And the function got updated, and that's it. We have that. And we can go ahead and test it, right? We can simply do it from the from this console itself. We don't have to go anywhere. So if I go to the test sort of area over here, so I can create something called a template, or sort of ready to build events using which I can test things out. Okay, so we have the hello world template, but I'm going to use something called the API gateway. So let me go back and show you this, right? So if I were to go back to the code, remember I told you we are going to use API gateway as sort of the input payload for this function, and that is why I'm using an API gateway testing template here, right? So this is what the payload is actually going to look like if you were to use an API gateway, by the way, right? So this is just for testing. So so this is not going to be encoded in any way. I'm going to send plain strings. So I've set base 64 encoding to false. I'm going to set a body, say AWS Punjab UG. So this is my body, right? And I will hit test and see what happens. Okay, so it failed. It's okay. I wanted it to fail. So let's see why it failed, right? So I wanted to show this to you because, when you're starting off, this is one of the typical errors you'll see, and because you're still new, you'll be like, what's going on, and this is going to be frustrating for you, right? So it says, fork exec, it's trying to execute a binary, and it says, hey, var task hello, right? This hello, there is no such file or directory. Why is that so? Okay, now maybe you have figured it out, but let me explain that to you. So if you look at the code section in the runtime settings, there's something called name of a handler. Okay, so by default it is hello, but if you remember, we had set the name of our binary as demo, right? So basically in the handler section, or rather the name of the handler, you have to set or specify the name of your Go binary, which you have included in the zip file. So the name of my binary in this case is demo. So I'm going to update it, save it, go back to the testing area again, and click test, and hopefully this should work right now. It does work. So we have a green signal. And what did we get? We got a response, the body. If you remember, I had added hello and exclamation mark. So we have hello AWS Punjab user group. And we can see the logs as well. So I had, if you remember, I had like a simple log.println here. So it says, okay, here was the payload, and that's it, right? Very simple, like, sort of a warming you up sort of a thing, and having a simple Go Lambda function up and running, right, on AWS, right? Now I'm going to move on now. But before I do that, because I glossed over a few points, because I'm coding and testing this thing right now live, but let me talk you through a few important resources, and I'm going to do that at the end of every section. I'll do this very quickly. So the first things first is I want to show you this Lambda package which I used, right? So this is the sort of Go doc for that. So if you notice AWS Lambda Go /Lambda, so this is the package we're using, and you can go and check out this GitHub repo as well, because this is core to the functionality, or the Go support for Lambda is core to this particular package. So you can go check this out later. I already have these listed as sort of resources in another GitHub repo, which I'm going to share with you. Don't worry, right? So I want to show you this package as well. And I was talking about a few signatures, right? The Lambda function or the Lambda handler signature. So you can sort of go and dive in deeper if you look at the documentation, but I just want to again give you pointers here. So if I scroll down, if you look, so there is like ample documentation in terms of it gives you guidance in terms of what a valid handler signature is, right? So there are so many options. If I were to scroll down, I am using this option, right? So I have a context object, I have like some sort of an input and a output and an error, right? So you can check this out later, at your leisure. And like I said, I'm going to be using API gateway, and I'll show that to you in action later on. So AWS Lambda sort of natively integrates. It has very tight integration with Amazon API Gateway, very well documented. You can check that out. And just as an FYI, even this API gateway has its own set of APIs or different flavors of APIs which it supports. There's something called a REST API. There's something called an HTTP API. I know it's confusing, REST, HTTP, what the difference is. You can read up on that in the documentation. It makes it very clear. And there's a WebSocket API as well. But just FYI, in this sort of a demo, I'm going to show you the HTTP API function in action pretty soon, right? So that's that. I just want to make sure you have pointers to sort of these resources which you can use later on once you sort of try this on your own. Okay. Okay, so I am going to sort of dive into the DynamoDB aspects. I need to keep moving on in interest of time. So I'll bring in DynamoDB into the picture now, right? And let me go back to my code. Now what I'm going to do is, yeah, because I'm going to continue with the same function, let me copy this part and just move this in this folder for now. And all I'm going to do is just copy this folder now, rename this to part 2. And I'm going to open the part 2 folder in a new terminal. That's all. So let me close this thing just so that it doesn't confuse you. Okay, so I have this is my second function now, which I'm going to let me delete this. Okay, so I'm going to sort of continue from here, and word wrap. And okay, so first things first, as usual, I'm going to pull in some dependencies, right? I need some, because I'm going to introduce the Dynamodb Go Sdk. So let me first get those dependencies to build this function, because it's going to interact with DynamoDB. So the important thing over here is, again, this SDK, or rather this package, for, which is going to give you it's a Go client for DynamoDB essentially, right? Nothing too fancy about it, right? So I'm going to start using it right away. Okay. So first thing, logically, what we need to do is have a DynamoDB client object created in order to execute any operation, right? So that's what I'm going to do real quick here. So I'm going to call upon the DynamoDB package, and there's something called a new function using which you can create a brand new client, right? And it accepts something. I'm not going to go into the details now, but basically what I'm going to tell you is this new, just give me a second. Let me go right again. Seems to be, maybe it was not pulled in earlier, but that's fine, right? Okay, yeah, all is good now. So this new function, right? Just understand for now that it creates a new instance of the DynamoDB client, okay? But what I'm going to do is I will not have this new function here in this handler. I'm going to move this out. And where is it? I'm going to move this, sorry, not here. I'm going to move this into something called an init function. And I'll tell you why. Give me a second here. So ddbc, this is just a name of the variable. Don't worry. I'm just naming it I'm giving it short names just for things to be easier for me. And this is going to be a pointer to be to a DynamoDB client object. That's all. Right. So why did I create an init function? So if you don't know init function, that's okay. You can go read up on that. But basically, init function for a specific Go file is sort of invoked whenever Go accesses that particular file, right? At runtime. So this is going to be invoked. It's like a static class in, say, a Java or maybe something else. I don't know anything else except Java and Go and a bit of Rust. So it's very similar to a static function, right? Sort of done during class loading, it gets invoked. So similarly, the init function also gets invoked, right? So what's going to happen is the value here is that this is a global variable, so the DynamoDB client. So if at all the instance of my Lambda function gets reused, right? If the same function gets reused for multiple invocations, the DynamoDB client creation does not need to happen over and over again. So because this is a global function, this is just going to happen once and that's it, right? And if the same instance of the Lambda function is reused, this call will not be repeated. Okay, so that's the value of the init function. Yeah, now because we have the DynamoDB client, I can use it to execute some operations within DynamoDB. Okay, so let me do that now. So ddbc, which is the name of the variable, dot. Okay, so we have it ready. ddbc dot. So there are a bunch of options, right? So there are so many invocations or operations on DynamoDB which we can invoke. So there is get item, as you see. There is delete item here, for example. There is update an item. Typical CRUD operations, by the way. Nothing too fancy about it if you've worked with a database CRUD, like create, read, update, delete. But what I am going to do here is use the put item operation to create a new entry into a DynamoDB table. Okay, so I'm going to call something called put item. Okay, it creates or replaces an old item, right? And what it accepts it's something called it accepts a struct as an argument, and it's called put item input. And what do you have in put item input here? You just have to specify two simple things. That's all, right? You have to specify, hey, which table, right? Which table do I need to, or I'm going to add this particular record to? So that's the first thing. So what I'm going to do, I can hard code the table name here, but just to demonstrate one good best practice to you is let's accept the table name through an environment variable, right? So I'm going to create a variable here called table. This is going to be a very simple string, and what I'm going to do is, again, in the same init function, I'm going to accept that as an environment variable. I'll call the name of the environment variable as table underscore name, and if we do not find this table, and if this environment variable value is not set, there is no point proceeding, because that is a sort of non-acceptable to us. So I'm going to say just sort of throw this saying, hey, you know what, no environment variable table underscore name is missing, right? I'm just having a random sort of, you can improve on this error message, but for now that's all we'll have, right? So we have the and I'll show you how to set this environment variable, of course, don't worry about it. So we have the table name here, so I'm going to set this, and in case you're wondering what is this AWS.string, so this table name and a lot of other sort of fields accept pointers to string. It's not just a string, it's a string pointer, and this is like a very sort of a helper function, right? So I can just do AWS.string and sort of convert this into a pointer. That's all, right? So that's first thing, table name. And the second thing is item. Well, this item attribute is nothing but it's basically the information about the record. Think of it as a key value pair, right? So in DynamoDB, and I'm going to show this to you, I will go to the Dynamodb console as well, create the table, share the records, but just FYI, it's a NoSQL database, right? So it's sort of a key value pair paradigm. That's what it follows. So there is a key, which is of type string, and the value can be like, there can be a bunch of things, strings, binaries, maps, lists, so on and so forth, right? So there are multiple values. So basically this item is nothing but a map of, so this is a Go map of a string to a pointer to a attribute value, right? And I'm going to show this to you. Don't worry, it might sort of seem confusing, but I'm going to break this down for you. So I'm going to create something called an item here, and I'm going to make this map, and just so that it compiles for now. We don't have anything in this item. We haven't done anything with it, but it compiles. We have a rough structure here, right? And I'll tell you, sort of what to do with item. What am I going to store in this Dynamo table? To keep things very simple, I have like very super simple example. I'll have a user data, I'll have email and name there. That's it, right? So I'm going to structure that in the form of a Go struct, very similar to a Java class, or I think JavaScript or Rust or whatever programming, or even Python, right? Python has classes. Again, nothing fancy here. So I'm going to have something called a type user, which is a struct. And like I said, I'll have an email information associated with it, and a name information, associated. These are just sort of attributes within or fields within that struct. And what I'm going to do is create a variable of the struct called user with a small u. And if you remember, I told you we need to pass on some information, right? Some payload to this Lambda function. In the earlier example, it was a very simple string, right? A very simple body was AWS Punjab user group. But in this case, what I'm going to do is pass in JSON payloads, okay? So in this request.body, I will have a JSON payload in the form of a string, but I will convert that in order for me to work with that JSON payload within my program. I will convert that into a struct because it is easier for me to work with within my program. So for that, I'm going to use the JSON package within the standard Go library. It's not an external package. So I'm going to say json.unmarshal, and it accepts a byte array, right? So let me create a byte array here. The byte array is simple. It's going to be based on this request.body, nothing else. I'm going to create a byte array from a string. That's all, right? And what am I going to sort of unmarshal this into? It's going to be a pointer to this user struct, right? So basically what's going to happen is the JSON payload is going to come through. This unmarshal function is going to get that in the form of a byte array and convert this into sort of a struct, and you'll have the email and the name fields populated, right? Simple. That's what is going to happen. This unmarshal function throws an error. I need to handle that. So let me do this. Error handling in Go is very, very common. You will see so many like error.nil sort of handlers. So here what I'm going to do is nothing fancy. I'll just return an empty sort of event here and along with this error, right? So my error handling is done, at least at a very, very simple level, for now. Okay, and let me go ahead now and sort of use this user struct values, which I'm going to get, right? So as I told you, we need to convert this into DynamoDB attribute values. And what is this actually? So let me actually create these values for you. Email attribute value, and let me create this, and this will be much more clearer to you. Okay, so the first thing while creating this value is you have to specify what data type it is. So I told you, right, the values in DynamoDB can be Boolean, it can be byte arrays, it can be sort of lists and maps, so many things. But here it is going to be a simple string, right? So a simple string, and what's the content of the string? It's going to be a pointer to a string. So I'm going to say aws.string and user.email, right? So this is where we are making use of our user struct attributes. And similarly, I like to copy paste, right? Like any good developer. So I'm going to create a name attribute value here as well. And I will simply use the user.name attribute, which I'm going to get through the JSON payload, right? So this is done. So we haven't made use of these variables, and that's why the compiler is complaining. So let me do that right away. So what I'm going to do is complete this map. Remember, this item is a map. Okay, so I'm going to put a couple of so what's the key here? I'm going to name this the first key as email. Okay, and the second value, sort of key as name, and I'm going to put this attribute value here, right? So just to summarize, right, we have an attribute value for the email here. We have an attribute value for the name here. We make use of the user struct, the values which we are going to get from these attributes at runtime when the Lambda function is going to be invoked, and we create the map here. And then finally, we pass on this value, or I'm sorry, the item, the map, to this put item call. That's it, simple as that. Now it has a couple of outputs. We don't need the first output. It's not, at least not for this demo, and it has an error. So we are going to handle that. I'm going to ignore the first part, which is by an underscore. You can sort of ignore the return of ignore a variable by putting a underscore. That's a Go convention. And I'm going to handle the error in a similar way. So I'll copy paste. I love that. So if I get an error in the put item, I'm going to simply log for now. And this is just, just to show you as a demo, put item failed. You should have better error messages, but this is just rough. And in this case, and I'm going to say, hey, you know what, unmarshal failed, just in case I need to figure things out while debugging, initially at least. I need to make a couple of other changes. I don't need this response object here. What I can do is as a part of my HTTP response, I need not have a body. But what I can do is as a status code. So typically the HTTP convention is you use something called a post request. And when you return and the post request is successful, you return a 201 response, HTTP 201 status created. So that's what I'm going to do. Status created, right? So I'm going to return a 201 response in case things are successful. And I'm going to log that as well. Say, hey, log.println, user created, and I can simply just, sort of output the email here, right? So I think we are fine. The function is ready. I'm going to just run through it real quick. I think it just helped me recap as well, just if there are any mistakes whatsoever. So we have an init function. We have accepted the table name, excuse me, as an environment variable. We have a Dynamodb client created. The main function does not change. We're going to ask Lambda to bootstrap or start our handler function here. And what do we do within our handler function? We get the payload from the request, just print it out. convert that into a struct using json.unmarshal. We create our item, which is a map of, again, key value pairs of strings and attribute values. We invoke the put item. There is an error, we handle it. We return it to the user or the client. If not, we are happy, user created, and we return a 201 response. Things look good, hopefully. Let's do this. So I'm going to again, do the same thing. Nothing sort of changes here. I'm going to build this function and deploy this in the form of a zip file. So go build. The name of my binary is going to be the same. I'm going to just use the same conventions. The demo binary. I'm just going to build this. And so we have the binary, and I'm going to create a zip file. So zip func.zip, and I'm going to put the demo binary here. Okay, so that is that. I'm going to hop over to the console now and upload this code. So back to my Lambda function. Just FYI, I'm using the same function. I'm not changing it. Like, there's no point, right? We can just update the code and sort of keep working with the same thing rather than wasting our time. So this is in my demo folder, part 2, function.zip. I just created it and I save it. If you see, this is 6.6 MB, slightly larger than our previous one, which was 4.5 MB, because we added additional packages and dependencies. I'm going to go a little quick here in the interest of time. So we have uploaded our code. I'm going to go ahead and create the Dynamo table, right? Of course, we have to create it. So let me go over, let me show you the Dynamodb console now. Close this and create my table. There are a lot of things going on here. So I'll create a brand new table here. I'll name it demo table. Yeah, demo table. Okay. And in terms of the primary key or the partition key, I'll call this email. And like I said, it's going to be of the type string. And this is the same thing which I mentioned in the code as well, right? So this is the only mandatory sort of attribute we need to create a Dynamodb table. Of course, we can have other things, but this is a NoSQL database. You don't need to declare schema upfront and everything. So I'm just going to keep things very, very simple. Have the email as my primary or partition key in this case. String data type, we don't need to change anything else. That's it. Create table. Boom. We don't need to complicate things, right? That's it. Done. The table is going to be ready in like a few seconds. And I'm going to go back, and remember, we need an environment variable as well. So I'm going to go to configuration of this section of this function. I'm sorry. Go to environment variables and add one. Okay. So I had called this table underscore name, and I just created the table as well. I think the name was demo table. I'm going to save this. That's it. Uploaded the code, created the table, added environment variable. Now let me go ahead and test this and see what happens. Same thing. I'm going to use this sort of the template, but the payload I'm going to use is different. Remember, I told you I'm going to use a JSON payload. I'm going to pass a JSON body here. So I'm going to copy and replace this here, and I've just delimited the quotations here. So I have email, which is user1@foo.com, and I have a name, which is user1. Simple. And that's it, right? Nothing fancy. I've just changed the body. I've not made any other changes. Let me go ahead and click test. It should fail. It failed on purpose because, like always, I want to show you this thing. It is very important because, again, this is an error which you'll encounter every time you're trying. I mean, at least when you're getting started and you're trying to integrate Lambda and DynamoDB, you'll see this. So what does it say? Access denied exception, user blah, blah, blah. This is my username, is not authorized to perform. What is it not authorized to perform? It's called dynamodb.putItem_call. So remember, I showed you that IAM role here. If I were to go back to the configuration. So basically, the problem here is this role does not have the permission to invoke a put item operation on DynamoDB. As simple as that. It just has one set of permissions. So let me go ahead and do that. I'm going to add an inline policy. It's just simple for the purposes of this demo, and I can do this via CLI and everything. I'm just using the console just to keep things very simple. I chose my service, which is the DynamoDB, and this is a very good experience, by the way, if you are getting started. So you can choose your service, and you can choose and you can look at all the possible actions. So in this case, I have a write action. And within that, there are different types as well, right? It's very granular in nature. It's very, very specific. So I could just go and say, I only want to give put item permission to this Lambda function. Just choose that, put a check mark here. I'm going to bump it up just in case you have issues seeing it. So put item, and that's it, right? And I can be very, and it's not like put item to any table. I can be very specific as to which table I want to specify, right? So I can say, hey, this table is in the US East 1 region. This is in this account, and the name of the table is demo table. Remember, I just created that, and I can be very specific and go ahead and review this policy and name this like DDB put item, just a very short name. For the sake of the demo, you should give better names to your policies. Just FYI, this is not a best practice. I'll create the policy. It should work fine. And if you see, it is created, right? And if I were to show you this in form of a JSON, it just allows the action which is allowed is put item, and what resource is it allowed for? Just this demo table. That's it. Not any table. So now I've created the permission. Now, hopefully, if I go back and test this thing once more, click on the test button here, boom, it works. Obviously, it's going to work, right? So remember, I told you I'm going to pass on 201 status code as a response if the entire process is successful. And if I were to scroll down a little bit and show you the function logs as well, remember, we have this got payload println function. This was the payload which we just sent. And it says, hey, I was able to successfully create this user, right? But really, the truth is, if you go and check the Dynamo table, right, we can't only trust the logs. So you remember we created this demo table. I can go ahead. So this is my table. Click on the explore table items button here. And if you see, we have one item successfully created here. Okay. So let me go back and show you just one more thing, right? Because so I can change up and create another user2. The name is also user2. Click on test, just to show you that things work. So looks like it was successful as well. Created user2. Let's go back to our DynamoDB table, refresh it, right? So yeah, it's all happening right now. So user2 got created as well. So cool. So far so good. No issues, no fires, at least not now. So 2 parts finished. The first one was a hello world Lambda function. The second part, I introduced DynamoDB. Again, very simple. I just gave you the demo of one function, put item. There's so many other things which you can do using the Go SDK for DynamoDB from your Lambda function. I just showed you one sort of an example here, sort of working end to end, right? What's next? What's the last part? I have about 17-18 minutes. So let me go to the last part here. And this is all about infrastructure as code, right? So let me go back to my my VS Code and create a new folder here. So we have part 1, part 2, and I'm going to create a new one, part 3. And what I'm going to do is open that in my VS Code and close this window for now. Okay, so I'm going to start off with infrastructure as code. And like I told you, I'm going to use something called AWS CDK, Cloud Development Kit. Now, everything I showed you, we created the Lambda function manually. We created the DynamoDB table manually, uploaded our code, updated IAM roles, added environment variables, so on and so forth. Now, I'm going to show you a hands-off way. Basically, I'm just going to write some Go code using AWS CDK. Just write a piece of Go code, and boom, everything should create it for us on the fly, and all we need to do is test our function. Simple as that, right? So let me start doing that, and I'll give you some context about CDK. Don't worry, you can always read up on that. So don't worry about it. I'm just going to show you that in action. That's the important bit, at least for in the context of this session, right? I'm going to sip some water for now before I kick off.
Let me buy that time.
Yeah,
Abhishek,
yeah.
There's a question in chat which says, in which use cases should we consider creating a Golang based Lambda instead of Node.js based Lambda?
Oh, very interesting. So see, I'll tell you, like I typically tend to, my typical answer is go, it depends, right? Why are you going to, so are you having issues with your Node.js functions? So it's a very, this question is going to be tough to answer if I don't have the context. So say if you have performance related issues with your Node.js function, or what is your reasoning, right? that is very important to understand before me or anyone else telling you as to why choose one over the other. In terms of Go, some of the benefits are from a programming language itself. Forget about AWS Lambda, right? It's simple to learn, simple to start off. From a performance perspective, your cold starts in Lambda are going to be much more improved. You can have a single binary and sort of work with that much easier that way. But again, for a Go versus Node, and I'm not a Node.js developer at all, so I'm sorry about that. But a Go versus Node.js discussion is very, very deep dive, very hard to answer. But I think I'm going to ask for more information, right? But if you were to have my recommendation, Go is again, like I said, very, very high performant language. So definitely something to think about in terms of your Lambda development. I know it is not the perfect answer. But unless, Amandeep, if you have any other context as well, sort of any more additional information for me to help answer that question, it will be helpful. But if not, I'm going to leave it at that.
That is the only part.
Right. So this is the only thing, right? Go or Node.js. Yeah. It's a very, very hard question, to be honest with you. I need more information to answer that question, to be very frank. Go is awesome. I'm not a Node developer, but yeah. I can take that up a little later as well, right? After I do this. So I'm going to move on. So yeah, so first things first, what I'm going to do is so AWS CDK has a CLI as well. So I'm going to use that CLI to bootstrap a project, sort of a ready to use template, so to speak, right? I'm going to bootstrap a project, so you don't have to think about like dependencies and everything else. It's very easy, right? So you see we have a structure sort of created right here. We have a Go file, we have a test file, blah, blah, blah. So it makes it very easy. All I need to do is go more tidy. Sort of the dependencies are going to be ready for me to use, right? And I can go and start creating my function, okay? So the first thing I'm going to do is open this Go file here. So if you see here, I have some boilerplate code already. I'm going to delete all that, right? So we need to create two things, like I said, from an infrastructure perspective. One is the Dynamo table, second is the function. So I'm going to start off with the Dynamo table. And for that, I need some dependencies because this is very, very specific to what I'm going to do. So I'm going to get that dependency here. So go get something called AWS Dynamodb Package. Let me see if that works. Maybe it's taking more time. But I don't want to waste time. Maybe it is already there in my local cache, and I'll see. So I'm going to use the AWS Dynamodb package to create a new table, new DynamoDB table. I'm going to do this programmatically, like I said. So this table is going to be part of this stack. A stack is a very, very CDK specific terminology. It's like a high level. This is what you're going to deploy. This is the unit of deployment, so to speak, right? So this is going to be part of this stack. I'm going to give it, just give me a second. I'm going to, okay, yeah, this is not ready. So I'm going to give it a name as well. 1 second. Dot string, and I'll tell you why I have to do this. And last but not the least, the most important thing is, just give me a second. Let me try this 1 second. Mod ID just for my compiler to work properly, and I'll get my code assists. Let's see. Let's give it a second just to make sure. If not, that's fine. Okay. Yeah, I'm sorry. Just. Okay. Yeah. All right. Yeah. So as you see. So what are we doing here? To create this new table, we need a bunch of properties for that table, right? So remember, I created the table manually. I gave it there was a partition key and the data type which we selected. So the same thing is here as well. I'm going to just specify the partition key for this table even during programmatic creation, right? So what is this partition key? It needs something called a DynamoDB called attribute. So let me create that for you. So DynamoDB, I'll define an attribute, and what does it need? It needs the name of the table, right? So I'm going to give it a name. Oh, well, you know what? I actually don't need to specify a name. I'll tell you why. I'll show that to you in action. CDK is going to create that for me automatically, and it's a good practice to not specify names. So I'll just specify the type. And what is the type, attribute type in this case? In this case, it is a string, right? So this is a string which we have, right? And the name of the attribute here, so I'm talking about the attribute name here, not the table name. The name of the attribute, if you remember, we were using email, and we are going to continue to use that, right? Because we have specified this already within our code, okay? So the type is string, and email is the name of our partition key. That's it. Very, very simple. We don't need too many other things to define our table programmatically, okay? What's going on here? Do we have... okay, I think we have a wrong set of dependencies. Don't worry, I'll fix that. Something like this. Try to... Just give me a second. Yeah. What I'm going to do is this, okay? Fix these dependencies, that's all. Don't worry too much about it. Let me see. Okay, things are better now. Okay, so it should compile all fine, because there's some, because I'm using the version 2, because and there tends to be dependency related issues. So yeah, okay, so we're going to name this DynamoDB table. This is not the name of the table, this is the identifier for the CDK. And what I'm going to do now is something called CDK synth. And what this will do is create a cloud formation template for us. Okay, it's okay if you don't know about cloud formation template, that's fine. It's basically infrastructure as code. It's in the form of a JSON or a YAML file which you can specify, right? And you can submit it to AWS and say, hey, just create these AWS services or components which I have specified in that cloud formation template, right? So whatever code I have written ultimately is converted to a cloud formation template, something like this JSON file. So if you see, if I want to scroll down, it has like 270 lines of code, right? Versus, you know, how many lines of Go code we have, right? And half of them are comments, right? We have about 50 lines of Go code here versus 270 lines. And this is just for one DynamoDB table, right? We're going to have more, and think about other pieces of infrastructure, much complex applications, right? So we have, so we wrote a piece of code, we converted that into a CloudFormation template. This is the DynamoDB table. We have the attribute name, the type of the attribute, and a string, and so on and so forth, right? So we have created the table. Now I'm going to create the function as well, and it'll all be done programmatically, okay? So for that, I'm going to use another dependency. I'll add that manually. The reason I'm adding it manually is because it is still sort of in alpha phase. I'm using the latest version actually. So let me add that directly to my set of dependencies here and use that. Okay, and I'll show you how it works. Okay, so I'm going to create the function. This is the name of the package, and I'm going to say new Go function. Okay. And I'll just do go mod tidy just to make everything clear and happy. Okay, so new Go function, it will be part of this stack, right? And I'm going to give it a name, a demo, or rather an ID. This is not the name of the function. This is just an ID for CDK. And what does it need? Just like our table, it needs a set of properties, right? What do I need in this function? Remember, you know, when we were creating it manually, we had to specify everything, right? So first thing, what is the runtime for this function? Okay, so we are going to use the Go runtime. Okay, so just give me a second. Sometimes the code completion takes time, so I'm going to specify go.1.x as the runtime here. And what's next, right? So there are a bunch of other things. Remember, there is an environment variable which we need to specify, right? So env, environment variable. And what is this environment variable? It is a simple map. It's a pointer to a map, string to string, right? So let's make that. So let's have that environment variable here. Okay. And what are we going to add? Remember, we had that we named it table underscore name. That's the name I'm going to give here. And the what's the name of our table, right? So I did not specify a name here. Okay, so here is the beauty, right? I'll show you this in action. So what we can do is this new table function gives us a dynamodb.table. So this is a struct, right? So we can have that struct here, and at runtime, what we can do is invoke functions or invoke methods on that object. So basically what you're doing, you have your infrastructure in code. You have your infrastructure is code right now, and you can call functions on this, right? So I'm going to call, say, at runtime, it's going to resolve the name of this table, which is going to be automatically generated, and it is going to be added as an environment variable within this Lambda function, right? So that's pretty cool. At least it was pretty cool to me initially, right? And there's one last thing, by the way, which I need to take care of, and which is, where is my Lambda function? Which Lambda function do I even need to deploy, right? I need to tell it to my code. Tell it to CDK via my code. So there is this attribute called entry, and this is nothing special. This is just the name of the folder where my Lambda function is. That's all. So you remember we had that folder called part2, right? So if I were to quickly show that to you, right? ls minus lrt dot dot, right? So in this part2, we have we have our function, right? Entire code here. Slash for just so that it's clear to you, right? So this is our function here. That's what we are going to refer to. That's it, right? We have our function which is ready. I'm going to name this, or rather point to this variable here named as function. And we need to do one more thing, by the way. Remember the IAM permissions. So again, I can do it simply via code. So what I'm going to do is I can call table dot grant write data. So this is a permission which I'm granting, right, on this table to this function, right? Doesn't it look very, I mean, it looks very, very intuitive to me. There is one drawback to this, and I'll show you what that drawback is. So you can simply, with one line of code, you can create that IAM role, add that IAM policy to it. It's super cool, right? I really, really love this, right? So if I were to run CDK synth again, it is going to create that sort of CloudFormation template for me. So let me run that and show that to you, show you the updated one. If I go here, if you see this JSON now, you will see multiple sort of types here, right? So we have the Dynamodb table. We have a policy here. If you see, right, we have an IAM policy. You will see so many. Oh no, I'm just 1 second. I'm sorry. Yeah. So there is a policy here. There's a function here, right? So we have so basically everything we have put in our code is converted into a CloudFormation template. And what I'm going to do is deploy this template. As simple as that. Okay. So for that, I'm going to call CDK deploy. Okay. And once I do that, what's going to happen is you'll see that in action, right? So it's going to do its thing, synthesize it, basically build that template internally. And what it did is it's just warning me, because I have a set of IAM role changes and things of that nature. I'm going to create new roles. So it's just warning me and asking me for this permission. But basically what's going to happen is, because I've said yes, it will go and kick off or submit that CloudFormation template within Lambda, within AWS, and then start creating all our infrastructure. Okay. So I will go. So just let's give it a second here, because okay. So creating CloudFormation change set. Now let me go back here and open CloudFormation. Right, so I'm in the CloudFormation console right now, and I know we have about 2 minutes. It'll be done in 2 minutes. Don't worry. The creation part at least. So if you see this stack, I didn't rename it. It's called part3 stack, and that's fine. Okay, the stack has the creation is in progress, and if I look at the resources here, if you see some of these things are sort of, they are still getting created. So you have a Dynamodb table. It's creation in progress. It has already created the IAM role. I can show that role to you while the other things are getting created, right? So this is a new role. That this is the name. It's randomly, automatically generated. So it's going to have all the permissions here. The other permission is not there right now. It's going to do that very soon. Don't worry. I'll show you this role. If I refresh things here, so these are all getting created one by one. So if you see, it is adding that, adding that policy and so on and so forth, right? Yeah, so all that's happening now, and I'm going to continue showing that. Yeah, if I hit refresh, So 5 resources created. If you see, it has created the table as well. If I go back here and refresh the IAM role, I just want to make sure that you see that, right? It's important to see things in action for you to realize that. So if you see, it has created this other permission, right? And here is the drawback. I told you there is a drawback to doing this via code. Now, instead of put item, you have so many permissions. Now, this is not a best practice, right? But you can be very, very specific in the code as well in terms of what permission you want to give. I did not do that just to save time because it was one function call. I want to take it easy, right? But you can be very, very specific in your code, okay? And let me, excuse me, go back to the CloudFormation. Excuse me. I refresh this and show you the table as well. I'm sorry. Yeah. So you see the name of the table. We didn't specify a name. It's randomly created. And if you look at the bunch of items, there will be no items here, right? We need to still test it. Okay. And of course, I need to open my Lambda function as well. So it created that. 1 second. Function. So this is my Lambda function, right? So this is the new one. I'm going to open it. I'm going to close the old function here. Right. So I'm going to, I can go ahead, test it out. I don't need to do anything else. Everything else will be created for me, this configuration of environment variables and everything, right? I didn't do anything manually. I just go, I can go ahead and be happy and just happily test my function, right? Same thing. I will have a payload here. Let me copy paste that payload because I don't want to write it by hand. I'll make mistakes for sure. The same thing, but I'm doing it for a different table. So just be aware of that. If I hit the test button, hopefully everything should work fine, right? Yes, it did work. Let me quickly go back to the table and not waste time checking logs and everything else. If I hit refresh here, you should see that sort of thing here. The user record created. I can go back and I want to show you one quick thing. The API gateway in action. I know we have crossed the time. I'll just take 1 more minute. If I add a trigger and create something called the API gateway, right? And this is just for demo. I'm just doing this manually from the console. I'm going to create an API. It just takes like few seconds to have this ready. That's all. So I'm sorry. I'm not going to authenticate or have some security. This is just for demo. Okay. So I'm going to create an API gateway with the help of an HTTP API and just added as an integration to this function, right? And I have this trigger right here. And what I can do is, instead of testing it manually, I can test it. I have this URL now, and it's going to invoke my Lambda function. So let me show that to you as well. Just 1 second. I'm going to use this latest URL, and I'll do this via curl. So let me do this over here. Okay. So what I'm going to do is curl. And I'm posting this JSON payload here of user2. This is my latest function URL, and that's it. It told me, oh, I got HTTP 500 for some reason. Let me check what happened. I think I might have the wrong URL. Maybe I don't know what happened. I got a 500. Let me see why. Still getting a 500. Okay, not sure why. The demo failed. There was a failure in the last thing. I'm still not sure. Maybe I can. Am I doing it for the right function? Yes, I have copied the right thing. I can actually monitor or try and troubleshoot it, but I'm not going to do that. Why? Because that's it. I mean, I'm going to leave it at this. There was, just to have this realistic look to it. I had a failure at the end, but it's fine. It will work probably for you. I want to highlight this GitHub repo, by the way, and I apologize. I've gone over 3 minutes. But this is something which is going to be right here. And before I do that, one more thing. I would really, really appreciate your feedback, right? And if you can just take out your phones, even if you're watching a recording, that's fine. You can click this. You can scan this QR code. You'll get a form, very, very short form. And please give us your feedback. I would really, really appreciate that. And maybe you already know, but AWS is a very, very customer obsessed and a customer focused and a customer driven company. So you are my customers for now. And I want to know how I can improve and what you like, what you didn't like, right? So please, give your feedback. And I'm going to really, go back and show you this this GitHub repo. And once you fill up the feedback here, you'll get the link to that GitHub repo as well. So don't worry about it. It's all public stuff, nothing hidden from you. So I can take a few questions now. I know I've gone over, but Aman, just in case, Amandeep, I'm happy to do that.
Yeah, there is one last question here which says,
Yeah.
Can we create and test AWS Lambdas in local dev environment, test and then deploy to AWS?
Yes, you can do that, and there are multiple ways you can do that. But I want to call out one thing. There's something called AWS SAM, or the serverless application model. So it is sort of a development tool, gives you that set of utilities and a dev platform using which you can do local dev test, right? That is a recommended way of doing it, but you could always, use the AWS Lambda CLI as well to sort of iteratively, upload your function using the CLI and sort of test it by passing payloads using that AWS Lambda CLI. But then I would recommend you use the serverless application model tooling, AWS SAM. I can actually show that to you. Oops, I'm sorry about that. Something called AWS SAM. Right, so this is what I'm talking about, AWS Serverless Application Model. This is something which you can definitely use for your sort of testing and local development iteration and that workflow.
Cool, thank you. Last question for the day would be, in which cases should we consider deploying an API versus creating a Lambda?
Creating an API versus deploying a Lambda. Okay, so just to clarify, right, just deploying a Lambda function, it's like just having your code in a piece of compute. You have a compute infrastructure and your code is there. You need to give it away. You need to provide a way for your Lambda function to be invoked, and only then can it do something useful. Now there's so many ways to invoke your Lambda function. So if you want to build sort of web APIs on top of Lambda, you have to use something called the API gateway or the function URLs, right? I'm assuming that you're talking about APIs or web APIs, right? So let me know if that's not the case. But if you were to build sort of an API layer on top of your Lambda, you definitely need something like an API gateway or a Lambda function URL. But you can also invoke your Lambda function asynchronously, say through something like Kafka or Kinesis and so on and so forth, right? I can actually go to the documentation. So if I were to show you AWS Lambda event sources, this is a good time to bring this up, right? And the documentation is a very, very comprehensive resource, right? So API gateway is just one of the event sources at the end of the day, right? So you have so many here. You have DynamoDB, you have Kinesis, MSK, and lots of other options, right? If I were to scroll down and show you working with other services, it'll show you list, right? So this you see this list. So yeah, there are a bunch of options, but yeah, assuming that you're talking about APIs, you definitely need something like an API gateway or a Lambda function URL to expose the capabilities or the business logic which you write for Lambda. Just having a Lambda alone will not help. I hope that clears. Yeah.
Thanks, Abhishek, and thank you so much for taking time out and share this knowledge with us. And hope to see you around again in another episode.
Yeah, for sure. Yeah, I'm highly available. I mean, that's not my tagline. I sort of stole it from somewhere, but I'm highly available. I'm there on Twitter, GitHub, LinkedIn, whatever. Feel free to reach out to me if you have any questions, and I appreciate your time and attention on this weekend specifically. Thanks so much. Thanks, Amandeep.
Thanks all for attending.
Bye. All right. Cheers.